Welcome back, everyone. Today's lecture is going to be about file management. When you are a data scientist, you end up drowning in files. You'll have them up to here, both files that contain data, files that contain your analyses, files that contain your software you've made, files that contain your reports that you're sending back and forth to people. It can get to be quite a nightmare, and obviously anybody who even has a hobby, let alone a profession in data science, needs to get quite familiar with different ways to manage files. So we're going to talk about that a little bit today. But we're also going to start with a little bit of logistics. So I know there was a lot of confusion, and a good chunk of it is my fault on reading number 1 quiz. I didn't have things ready in time for when I promised you last week, and so the R1 quiz is going to release at the very break of Thursday morning at 12:01 a.m. as soon as Thursday begins. Okay? And you're going to have 48 hours to get that reading quiz done. And that means that the quiz closes at 11:59 p.m. on Friday. So all the way through both Thursday and Friday, California time. Those things will be the quiz will be available for you to do on Canvas. Okay? So also along the lines of readings, the next one's going to become available right when the quiz hits. So reading 2 will come out, and a week after that, I'm going to also do the same thing. I'm going to give you a week to read it, and then you'll have a quiz which is open for a 48-hour window. So we're going to be on a time lock of Thursday, Friday reading quizzes, okay? And as a reminder, in Friday discussion sections, you will indeed talk a little bit about the reading. So, let's see what's up. Today's learning objectives. We want to describe to you a reasonable way to manage your file structures and make sure that your projects look organized and not like your sock drawer. Okay? And one of the tools that we are going to advocate for is to get familiar with version control software and the basics of how it works, because version control is a powerful addition to anybody's life on a computer, whether you're a computer programmer, data scientist, or anything. All right. So before we get going, I want to take a look at the data from your course survey. So everybody said that, we had kind of an even-ish distribution of people's level of familiarity with programming, okay? So, sorry, let me kind of back this up and show it this way. So this is how familiar people were with programming, with a 10 being very familiar, can teach an intro to programming course, and 1 being, I don't know anything about this stuff. So I just wanted to remind you that people in our class were mediumly evenly distributed about how familiar they were. If I was going to draw the histogram of it, it was probably going to look pretty much even with a peak over here and then back down to even, okay? But here I'm taking those people and I'm splitting them up into those who were familiar with version control on the right-hand side here, and those, unfamiliar with version control on the right-hand side, and familiar with version control on the left. So only about 50 or a little less people are familiar with version control, and that's out of 380 roughly. Okay, so very few of you are familiar with version control software already, so that's why we're going to talk about it. The unfamiliar people are pretty evenly distributed, roughly like the distribution of programming ability itself. So, and those ones who are familiar with version control tend to be those who are more familiar with programming, because programmers are kind of like where version control comes from. And if you run in programming circles, you will definitely find out about version control. Okay? Well, so why am I showing you the plot this way? Well, this is kind of also another one of my introduce you to various ways of communicating visually with data, okay? This is called a category plot, and what I'm plotting here are raw data points, right? Each one of these dots is an actual person's response. And in here, where you have like gazillions of dots, they're being spread up enough that you can kind of see how many dots are on there, but when there gets to be a certain level of way too much data density, it does disappear. So this kind of a thing is a standard way to visualize categorical data against a numeric value, like how good are we at programming. But this kind of raw data thing can get really overwhelming if you're dealing with thousands or millions of data points. In that case, we don't show you the raw data, we show you a summary of it. So one way that you might see a summary is with a violin plot. What a violin plot does is it looks a little bit like a violin, but it actually contains information about the data. So the median value is a dot right in the center, and these little bars are showing you the spread using percentiles, okay? And the blue shape is kind of like an estimation of that probability distribution. So it seems that this distribution is got the most people kind of around here, and it's very few people running down to the tails here, right? So it's like imagine a cumulative distribution function if you've seen one of those before, and if you haven't, don't worry, just imagine this as like an add up of how many dots are here, and then a nice smoothness put over the top of it. So the orange, the unfamiliar, looks pretty even. There's roughly as many people who are unfamiliar with version control who have an 8 for familiarity as those that have a 2. Okay? Now, a third way to show this is from our friend John Tukey, who you read about during our first reading. John Tukey is the inventor of the box plot. And the box plot is kind of like the 1960s version of the violin. It shows you where most of the data lies, this is the median value, and where the range of data lies, that's the edges of the box, and the most extreme versions of the data are the edges of the whiskers. Okay? So these are 3 different ways to look at the same data. All 3 of them show that if you're familiar with version control, you're probably a better programmer than most people in the class. Okay? And again, I just showed you all the different graphs because this is a class on data science, and we're starting to get you familiar with the kinds of things data scientists do. And you will see in your career violin plots and box plots showing you differences between categorical things like familiar or unfamiliar with version control. All right, well, let's get on to the topic, which is managing your files. And one of the first elements of file management that I'm sure even just in your academic careers going to college or even high school, you've already encountered stuff like this, is doing revisions on some document. And you're working on the report and you're going to send it, and you send it in, and then you're like, oh no, I made that mistake. All right, well, let me send in a new version of the report. And then you get like corrections back, and then you're like, oh, here's the 3rd version. And pretty soon you've got this multiplication of stuff all across your screen where you have no idea which one of these directories actually contains the real deal. I did it multiple times here in the 2000s. So this was a book I worked on. I had 3 different versions of it running around my file system for some reason. And then months after the fact, I had to figure out which one was the real version. I might have been wrong. This one down here is just crazy town because I had so many versions of it running around on several different computers that after I was months past finishing the project, and I was like, I need to clean this stuff up and make sure I have an archived version of the actual thing that went to publication. I spent like probably half of a day trying to figure out which one of these was the right one. So, there are many different ways to fail at this kind of thing, right? This was if you email things back and forth with people you're working with, right? You're in a project group in this course. If you all start emailing back and forth your revisions, it's going to get unwieldy fast. What if like 2 people make changes in the document and send 2 emails a minute and a half apart? Yeah, it's kind of crazy, and you can end up in a lot of trouble that way. Also, you can just end up stacking up various versions of the emails and misapplying one of them to the final product, right? If you have 3-4 emails with corrections from 3-4 people, that way lies trouble. So you also end up with situations like this, like I was saying actually just a few minutes ago, where, oh, this is it. Oh, wait. Nope, I made a mistake. I just realized. Here's another version. Oh, God. I gotta send that message a 3rd time. Well, how can we avoid this? There are tools out there that are built to try to help people manage revisions of documents. Your Microsoft Word has track changes built into it. I hope you've used it before. If you haven't, then I suggest you do, especially in a project situation like you're going to have in this course. Now, beyond Microsoft Word, Google Docs is an even better step in the right direction, because with Google Docs, you can have 2, 3, 4 people editing the document at the same time, right? Remember our emailing back and forth with 4 collaborators, and 2 of them send you changes, and now you've got to take 2 separate files, combine them into one. You don't want to be doing that. And again, you might miss one of those 4 emails and miss out somebody's changes completely. So a sharing situation like Google Docs lets everybody edit together in the same source of the document, and each person's individual changes are noted by color, and there's a list of who did what and when. And there's no way you miss out somebody's contribution, because Google makes sure all of them are integrated into a single document. And if you want to go back in time, you can click one of these and undo it. Okay? So these kinds of tools, track changes tools, and Google Docs, even more than Microsoft Word, start to address this problem when you are writing a report, say. They're highly recommended. Please do use these tools when it's appropriate to do so. But Google Docs is not the same thing as version control. So what version control is it's a programmer's version of that, meant to manage all kinds of files, including, for instance, text documents like this, but also text documents like a program. So here is a bit of applying Google Docs into a, oh, sorry, is this Google Docs? No, this is version control inside of a LaTeX document. So yeah, actually, because this is Brad's slide, I'm not even sure. I do think this might actually be Google Docs holding a LaTeX document. So for those of you that are not familiar, let me back up a second since I'm all confused. LaTeX is a way to write that is different than a word processor. So in word processors, right, you change formatting. You're like, oh, let's make a heading and let's make it big. Let's put it in boldface. In LaTeX, you completely change the way in which the document works. The document actually becomes a computer program. So you separate out what the document says with things that the document needs to look like. So, for instance, if I put together a report and I'm sending it to one particular kind of journal, somebody who says that all of the citations have to have numbers, 1, 2, 3, 4, 5. And then it gets rejected and thrown out of that journal, and I need to send it to another journal, and this journal prefers citations to look like Smith, 1993. Well, instead of having to rewrite all that, a LaTeX document, the formatting is completely separate from the document itself. So I just change which style gets applied to the document, and when you compile it, just like you compile a program, you get an output, which is, the combination of the actual document and all the markup that is part of saying how this document should look, and a style file. A style file says what a given boldface should look like, or what a heading number 1 should look like, or what a citation should look like. At any rate, don't worry too much about it, but the point of LaTeX is to separate out a document's contents from its prettiness and enable you to compile it like a computer program. So you can do that kind of stuff. You can make documents into programs where things are able to be tracked and made and changed easily, or changed back to the way they were. So version control, to get back onto topic, is just a way in which we can make sure that multiple people can work together on a project, or also ways in which you can manage the history of how a project has changed through time. Those are fundamentally the same thing in the way version control works. So when you are doing version control, each person is going to be operating on their own copy of the files. And each person gets their project to wherever they think this is a stage where I want to share it with everybody else. And then they can use the version control system to share their changes with the rest of the team. Okay? So temporary or partial edits by one person don't interfere with somebody else's work. But the version control system seamlessly integrates all of those, whatever is each person's current contribution that they've shared with others, integrates it all into one single viewable project. Now, even more than that, it is also a way to manage how files change through time. So if you have made a bunch of changes and you go, oh, no, wait, I want to go back to the way it was on October 2nd because I've just realized I was going down a dead end. Well, you can do that. You can head back to the October 2nd version of your own work or of everybody's work. You can have the current version of everybody else's work and just revert your stuff to October 2nd. Sounds very powerful when you put it that way, right? Because that way you don't have to interfere with all the work everybody else did when you want to go back on your own chunk and start again from a given point. So how can we do that? What is the way version control works? Well, every single time that you send the version control system, you tell it, okay, this is a new update for my work. Then it's going to keep track of all those different versions of the files. Version 1, version 2, version 3. And even better, from the standpoint of, this is a computer system and eventually I run out of hard drive space, it doesn't just save version 1, version 2, and version 3. No. It saves version 1, and then it saves only, I'm going to use the Greek letter delta here, only the changes from version 1 to version 2. Okay? And then it saves only the changes between version 2 and version 3. So in that way, it minimizes your disk usage, right? It starts with the original version, and then it just stores the changes. And anytime you ask the version control system, you say, hey, bring me version 2, because I want to undo what I did with version 3, all it does is it undoes those deltas and gets you to that. Okay? So, you have many files, of course, and each one is managed separately. So every time you check in a file into version control, you're going to get deltas on each ones of these. Okay? And so on and so forth. And when you're operating on a bunch of files, you can pick and choose undoing things in the history on any one file or on all of them. So it is a very powerful way to manage the evolution of the files. Okay? So when you're using the version control system, when you're editing, when you have on your computer, is only just the copy you checked out, and that's it. All that history is invisible to you until you ask for it. So the thing which is the storage unit for all of these files and all of their history and all of the deltas is called a repository. It's the set of files that are being tracked by the version control system and that you are managing. And it's the repository where you say, I want October 2nd's version, or I want the newest version, or whatever you want. So there's a lot of different pieces of software that you can use for this. By far, the most popular at this point in time is Git. Okay? Git has, got all the market share at this moment, but as with all things computing, there was a point at which Subversion was the hot new deal. Okay? So I'm sure that eventually something will come in and replace Git. But for right now, it's been quite dominant. Git also makes available a lot of cool tools for people. So you have not just Git itself, but you also have a website called GitHub. GitHub or GitLab or other things are where your actual storage can be. So wherever your repository sits, whereas Git is the software that manages that repository. So GitHub is kind of nice because it's available on the web. It gives you a lot of storage for free, and you can just start using GitHub, and it's always available wherever you can be connected to the internet. So you can leave all your software and projects on GitHub, and you can use that not just for your own storage, but also for collaborating with anybody else who can reach the internet. Okay. So again, Git itself is the software that manages the versioning. It's like the track changes, but with lots of extra features. Okay? And GitHub is where you keep your stuff. It's your storage. It's like Dropbox or Google Drive, but way better because it has all these features attached to it and the ability to share in many ways that Dropbox and Google Drive don't give you. Okay. Here's what it looks like when you use Git. You can do things on a terminal, like all good hackers, right? And when you want to get a repository, you want to bring a copy of the repository that's on GitHub down to your computer to use. Well, you can just ask to clone it. And you clone it from a website, GitHub, and you tell GitHub which user you're cloning their repository of and which repo that you want of theirs. And once you've got it, you can do things. You can make all your modifications, do whatever you're doing to the files, and when you're done, you can add the new files and the new work you've done. Then you can make a little comment about what it is that you have done to these files, and then you can send your changes up to GitHub and say, okay, here are the changes, now everybody can see what I did. Until you do this push command, nothing you have done is visible to anybody else. It's all on your computer and your computer alone. Okay? You can change things before you send them out. You can be keeping a history of things on your computer. You can do more commits locally with Git and make sure that you have a way to back up your work to some previous state. And you can do that for days, months, or years before you finally feel like your work is ready to share, and you push it up to where you got it from so everybody can see it. So this is just a little view of what GitHub looks like. And you can see all the different repositories here that are on my front page. And so when you find one of these repositories that you want to use, that is the web address. Is the web address of that repository, which just goes in there when you're cloning it and bringing it down for you to play with on your computer. All right. So what is all this good for? Well, you can collaborate with people, right? Because multiple people can be working this way and then integrate their changes when they push. Okay? If you need to go back to this was working and, like 3 days ago and now I just broke it because I've been playing with the software, you can return to a safe state by going back to 3 days ago. You can also use this to expose your work to other people. I may have mentioned in the past that in the kind of Silicon Valley computing, machine learning world especially, there's a lot of emphasis on how many commits have you made to other people's projects, right? So like other people have big software projects out there and you make small improvements and send them out. So GitHub, your history of commits on GitHub is part of your resume. It's part of like demonstrating that you're a good programmer or data scientist or something like that. And likewise, as you are getting exposure, you can track other people via GitHub. It's a social network as well as a place to store your files. So people can expose themselves and make other people understand what it is that they've got in terms of skills and, reasons to work together. And likewise, you can track other people's work and say, hey, I really like that person's project. I would love to contribute and, see what I can do because I think their work is really fascinating. So again, how does this work? Each person is making changes locally, right? On their computer. And only when you're safe, where you feel like, you can just make all these changes, you can try things, you can break things. Breaking things is totally an important part of programming stuff, okay? Only once you're sure that everything you've done is safe and tested and ready for other people to use, can you then send the changes back up to GitHub at that point. By the way, if anybody's wondering, the emblem here is called Octocat. It is a combination octopus and cat. There's a history. You can go look it up. So anything you do that's public in your GitHub can be seen by other people, and in a way it's your social media. It is your own version of programmer Facebook or Instagram. Okay? As a social platform, you can also see other people's work. So here's an example of a GitHub repo, and I'm going to take you through a few things. So this GitHub repo is mine, and it started when the coronavirus first hit, and I wanted to get a sense of how things were happening in our local area in San Diego County. And at the beginning of the pandemic, the county was putting out some information on the web, but not a lot. And they were only telling you about today. And it is vitally important to understand how things are going to see the trajectory of, is stuff getting much, much worse, or is it starting to get better, right? And since the county wasn't giving us any history, I was like, I'll do it myself. So I started scraping up their data. I started for a couple of weeks just keeping track of stuff. It was just for me, but I was using GitHub as a way to maintain my work and keep things going. Now, after a couple of weeks, I started to hear a bunch of grumbling in the media about people like, all this pandemic stuff, it's not really important. We shouldn't be doing all this, yada, yada, yada. There's no effort that we're doing that's going to help us out, various people were saying. They were getting angry at the isolation and the masks and all that good stuff. So I ended up taking my work and turning it into an op-ed, an editorial opinion piece in the local newspaper, in the Union Tribune. And GitHub really helped me maintain the work so that I could do something like that, right? So let's take a little tour here. I'm going to, hopefully, be able to give you a live demo of the GitHub. There it is. All right, let me get over to that window myself. Okay. So what you're seeing here is the repo. And I can go dive down in anything here, right? I can go into the plots directory, which contains output of a bunch of plots. And I could look at a particular file. Okay, so here's a given output that my program made. Okay. When I want to, for instance, get this whole repo and check it out and see it on my computer, all I need to do is click here, right? Now GitHub, there is I showed you the command line a minute ago, but you don't have to use the command line. There is an app that you can use. So you can download the app and open it with the app. You can download a zip file, or you can just grab this address and use it the way we showed you with a git clone. All right. Now, one thing you'll see here is this. There are 67 commits. 67 times I, over the course of a month or two, pushed small changes of code or big changes of code and data up into GitHub. And, you know, this is the time history. This is the evolution of this stuff. So the most recent commit was on April 30th. That was when I stopped updating my software. So you'll see in each one of these commits, as we go backwards through time, I have to say something about what it is, what happened. Okay? So sometimes my comments are not very useful. What did I do there reformatting the code section? Why? Okay. But sometimes it is. I updated the optimistic hospital bed predictions and minor cleanup of words. Okay? So sometimes it's very clear, but at least these comments give you a chance to tell yourself a year from now what it was you were doing there, right? And help you understand what each one of these changes are in case you need to undo one of them, right? So this is vitally important. And anytime you want to get back to a particular version, this is a unique tag which tells you, gives you a link to grab exactly that version and not, say, the current version, the most recent one. Okay? So don't get too bound up in this. This is not a how to use it guide. This is giving you a sense of how the whole system works, giving you a way to think about the fact that a version control system like this has a lot of power. And you can get a lot of different kinds of things going on here. Okay? Other people can make changes to your code and then say, hey, I would like you to incorporate my changes in the main version of the code, which is available to everybody in the world. And if that's true, they'll send you a pull request. And you can integrate other people's interesting contributions to your projects. Or you can just invite the 4 people you're doing the final project with to be part of this repo, period, and you can all just make commits together, right? The pull requests feature is for people who are, you don't know, who just see your stuff on GitHub and they go work on it and they make a cool extra and they want you to be able to pull that extra into your own work. Okay? Let us head back to the presentation. Yeah, sorry, this is that's the version I wanted. Okay. So, I skip over that. So, again, this is just the way it works. You clone that stuff, bring it down, work, add your changes to the hub, commit, and push. And this is what it looks like when you use a desktop version of it, right? It lets you track the changes. So this is the list of commits that we saw on the web, and you can see how they're all related to each other, and you can see all those comments and see those unique tags which let you grab a particular one. Okay. So let's take a little moment to do some interaction. Why would you do version control? Well, we've given you a lot of reasons, but one of these things is not true. One of these things is not a reason for version control. All right. So, FYI, what I was asking right there is that I was just seeing how much you were paying attention and in terms of the nitty-gritty details, because this is, in my opinion, the wrong answer, because it doesn't save multiple copies of the files. It saves the deltas, right? So you can go backwards to any copy, but you don't save many copies of the files. So again, you're not getting any points or losing any points for that. I was just curious how much you could understand of the nitty-gritty as I was going through. Okay, file naming is a big deal. It can be very helpful to make sure that you can find the data you want a year from now. Because a year from now, you're not going to remember this stuff. You've probably already experienced this in your college career, where you go back and you look at something you did, like, you know, in 2 classes ago, and you're like, I don't remember why or how. Okay? So, especially when you're working with data, you have to document what each part of the project is. And therefore, the files should be easy to find, easy to share, easy to understand, and easy to update. If you can't find your stuff, you're screwed. You're done, right? And if other people can't understand what you did, or you can't understand what you did a year later, then you're also going to be screwed. So the file names can really help out with that. And likewise, you know, if you want to share that with people so they can understand, if your file names are not usable on another computer system that chokes when you use funny special characters, right, you're going to have trouble. So what does that mean, right? Remember that you 6 months from now are not going to remember what went on. And you also have other people you want to share these results with, or enable them to reproduce your work. Okay? So also people are going to give you comments and ask for changes. So can you redo something this way? What if we drop 3 people from the analysis, right? What if we try this new machine learning cool thing? Okay, so you are iterating with other people, and proper file names help that communication. So Jenny Bryan is somebody who is a professor of data science and started a master's in data science at University of British Columbia, and she's also quite a prolific software engineer for the major data science project RStudio. So listen to what she's saying, right? She knows what she's talking about. File organization and naming are your weapons against the chaos of so many projects. So if you set up your projects in the same file structure every time you use a project, you are going to be so much happier, because you're going to know kind of how to navigate through the project's data structure, because it's always going to be the same. So the file structure we're showing you here does not have to be the one you use, but whatever one you use should have nice features, and it should be yours, and you should always use it. Okay? Don't change it up for one project to another. So put your files in structures that are easy to understand, with words that are clear and concise. And since you want to use this again, don't use things that are hyper-specific, right? Don't say, you know, data for machine learning, or data of cat videos, right? Just say data, because now you can reuse this structure on another project. Okay? And make sure that you use naming conventions inside these structures that are very clear, right? Raw data, tidied up data, exploration figures or things that explain stuff, raw code and final code. Make sure that the names of files convey information, and likewise, you can again use these generic naming things rather than very specific things, so you can use the same project structure again, and again. So file names should also be machine readable as well as human readable. So let me tell you that when you work with large amounts of data, you will have, say, hundreds or even thousands of files that you're reading, and they're all generated by the same kind of thing, but like, say, different runs, or they came from different locations, or they were processed by different people. And you're going to end up in your data science project literally loading 1,000 files up. Well, if the files are set up in a nice structure that enables you to do that with a computer program, perfection. If you have to write 1,000 file names into your code, you're going to hate life. So various things you can do can make sure your file names are good. Don't put spaces in them, like Jenny is saying here, because that can choke computers, and people may be able to see it, but other computers and software tools can often fail with funny characters like spaces. So replace spaces with things like underscores or dashes, and make those underscores and dashes mean something. Okay? When you have multiple versions of something, when you use dates, okay, use clear dates. Use the same date system all the way through. Okay? Use keywords that are easy to search for, right? You're like, if my project involves knowing, that I have mutants and normal versions of the same data, right? So this is biology here, clearly. So we have mutant mice and normal mice. Then if I have a keyword search for mutant, I can find the data that I want quickly. Okay. And if you have versioning like, versions 1, 2, and 3, then use a uniform way to delineate that version. Okay? When you can't have spaces, you use underscores and dashes, and you can use them differently to mean different things, right? So the underscore here in this naming convention is separating out parts of the file name, right? So the date separating an identifier of the kind of data it is, what kind of a machine and experiment produced that data, and then an underscore, and then all of this, which is a description of what particular version of this data it is, right? So it's date, kind of data, description of this data, okay, and then a versioning or something like that. So use your file names to your great advantage. And by the way, please, 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 when you write dates, write them like this, because that is a standard international way to write a date. Americans, like me, grew up writing month, day, year. And the rest of the world writes day, month, year. And since nobody can get rid of their system because culture has inertia, let's just get rid of it always. And every time we use something in machine land, let's use year, month, day. And it's got a natural sorting ability, right? When you sort the file names in your Finder or, file manager or whatever, when you sort numerically, this kind of a date name sorts properly, okay? And you're going to see this 27th is going to be right before the 28th, is going to be right before the 29th, and all of February is going to be together, and not mixed up with March. So this gives, like, remember this is like, being able to easily organize your files and just use them. So these are examples of terrible, terrible names, right? If you put in weird machine characters like E umlaut, that's not going to work on somebody's machine. You're going to hand somebody this data and it's going to not be able to be read because somebody's machine is old. Okay? Use these underscores instead of spaces. Make sure that, like if you're going to do natural versioning, like leading numbers are actually a really common data science thing where you say, like, in this directory, say I did 10 analyses and they go in order, 01, 02, 03, 04, and you have to iterate through them to make the full analysis. So using leading numbers is a natural way to tell you what order to execute something in. Okay, let's do a little quick check-in, right? Within a project directory, which of these is a good idea? By now you've probably figured out it is all of the above. So, which of the following is a best version of a name? So that one was actually an aesthetic choice. There is objectively more information when you add in a number. And so it kind of depends on what you're trying to convey here. If you're trying to say, read this one first, then probably something like this is the best way to do it, or this. The difference between the two being underscores for spaces versus what's called camel case. Camel case is a very old-fashioned way by now to do this. So I feel like people are definitely converging on this. So in some sense, this might be the right answer, but it kind of depends, because camel case versus underscores is an aesthetic choice, and whether you need that 01 depends upon whether there's a natural order in this directory. Okay, so I just want to close out by maybe just noting the date stuff one more time, which I went past. So I'm going to tell a little story to close us out here. When I was doing my PhD, had a half birthday. And it just goes to illustrate how easy it is for different standards to mess you up. So I had a meeting with my PhD supervisor, and he called me into his office, and he handed me an envelope, and he said, "Open that later." I was like, "What?" "Okay, I will." He's like, "What'd you do last night?" "Nothing. I just kind of had a quiet evening at home." "Oh, sometimes that's best." I had no idea what he was on about. So we had our meeting, did all the researchy stuff. I got back to my seat. I open it up, and it's a birthday card, and it is not my birthday. On my application form for the PhD, wrote my birth date in the American way, month, day, year. Them being Europeans, where I did my my PhD, they assumed that was day, month, year. And my supervisor was exactly the kind of person to have that, ready, that birthday card. I was just I was so embarrassed. I never told him. Spent 4 years with him giving me birthday cards on the wrong date, and all the other PhD students laughing their butts off. So, moral of the story is, if you don't understand how data is notated, and if you don't have uniform standards, you too can end up with a half birthday. All right, thank you very much for your attention. I hope everybody has a good couple of days. I'll see you on the next lecture.